Hello everyone and welcome to AWS Application Integration Services Selection or Decision Guide. This is one of the most important lecture of the entire course. I will go as far as saying that if you watch this lecture completely and pay attention, then you will most likely be able to answer all the application integration related questions. Most exam questions will ask you to pick the right application integration service or will try to confuse you or trick you into choosing between similar application integration service. So if you go through this lecture, then hopefully you will be able to tell the differences or similarities between these application integration services clearly. So this lecture will contain all this topic: service category, primary function and purpose, and communication pattern, service model, management effort and deployment complexity, scalability approach, typical throughput and typical latency, message event ordering, delivery guarantee and message event persistence, availability design, fault tolerance features and durability concept, primary cost drivers, pricing model and cost optimization strategies, primary use cases, less suitable for and key differentiators, key concepts for certification, common exam confusion points and important limitations to remember. So these services are covered as part of application integration. Amazon Simple Notification Service SNS, Simple Queue Service SQS, Amazon Event Bridge, Amazon Message Broker Service MQ, Amazon Kinesis Data Streams, Amazon Managed Streaming for Apache Kafka, it will be denoted as MSK, Amazon Managed Workflows for Apache Airflow, it will be written as MWAA, AWS Step Functions and Amazon Simple Workflow Service. So first we'll go through all these parameters. So service category, primary function and communication pattern. So we have Amazon SNS. This service is a fully managed publish subscribe messaging service. Publishers send messages to logical access points called topics, and SNS push these messages asynchronously to various subscriber types, including SQS queues, Lambda functions, HTTPS endpoints, email addresses, mobile devices via push notifications, and SMS numbers. Its primary strength lies in broadcasting message fan out to decouple applications and deliver notifications for both application to application A to A and application to person A to P. Next, Amazon SQS. This provides fully managed message queues to decouple and scale distributed systems. Components send messages to a queue and other components called as consumers pull. So this is a pull, like pull the queue to retrieve and process messages. Typically one consumer processing a given message. This pull based asynchronous model makes it ideal for buffering work, managing task backlogs and ensuring reliable processing. Next we have Amazon Event Bridge. This acts as a serverless event bus, enabling event-driven architectures by routing events from diverse sources like AWS services, SaaS applications, and custom applications to various targets. It goes beyond simple pub/sub by offering content-based filtering, event transformation, schema discovery, validation, and features like pipes for point-to-point integrations and scheduler for triggering events. This positions Event Bridge as a central hub for reacting to changes across an entire system, reflecting a broader architectural pattern than a traditional messaging system. Next, we have Amazon MQ. It offers managed instances of popular open source message brokers, Apache ActiveMQ and RabbitMQ. Its primary purpose is to simplify the migration of existing applications, which relies on standard messaging protocols like AMQP, MQTT, STOMP, JMS and NMS. To support hybrid architectures, it provides compatibility while offloading the operational burden of managing the broker infrastructure. Next, we have Amazon Kinesis Data Streams. This facilitates the ingestion, processing and analysis of large volumes of streaming data in real time. Data is organized into shards and records within a shard maintain their ingestion order. It supports multiple consumers reading concurrently and is often used for real-time analytics dashboards, log processing, and clickstream analysis. Next, we have Amazon MSK, Managed Streaming for Apache Kafka. This provides a fully managed environment for running Apache Kafka clusters. It caters to users who need Kafka's specific partitioning, replication, and ecosystem capabilities like Kafka Connect and Kafka Streams, but want AWS to manage the underlying infrastructure like brokers, Zookeeper, and KRaft nodes. Use cases include high throughput event streaming, log aggregation, and databases. Next, we have Amazon Managed Workflows for Apache Airflow. This is a managed service for orchestrating complex workflows using Apache Airflow. Users define workflows as directed acyclic graphs (DAGs) in Python to schedule, monitor, and manage sequences of tasks, often involving data processing, ETL pipelines, batch jobs, or machine learning pipelines. MWAA manages the Airflow infrastructure that includes schedulers, workers, web server, and database. Next, we have AWS Step Functions. This is a serverless workflow service that orchestrates distributed application components using state machines defined visually or in JSON. And this is a Amazon state language. It coordinates tasks, often Lambda function or other AWS service integrations, handles errors and retries, manages state, making it suitable for automating business processes, building data pipelines, and coordinating microservices. It offers standard, which is long running exactly once, and express, high volume, short duration workflow types. And last, we have Amazon Simple Workflow Service. This is an older, fully managed workflow service that coordinates work across distributed components using the task-based worker decider model. Deciders implement the workflow logic while workers perform the tasks. SWF tracks state durably and is designed for long-running processes where tasks might take significant time or require human intervention. While still available, step function is generally recommended for new development. So next set of parameters that I will be comparing will be service model, management effort, and deployment complexity. So first we have Amazon, we have three actually, SNS, SQS, and EventBridge. So these three services are serverless and fully managed. AWS handles the provisioning, scaling, patching, and availability automatically across multiple availability zones. This results in low management effort. Deployment is typically simple, often involving API calls or console configuration. Next, we have Amazon MQ, a managed service using provisioned instances. Users select the broker engine, instance type, and deployment mode. Management effort is medium, involving initial configuration and potential adjustment, though AWS handles patching and failover. Deployment complexity is moderate, especially for high availability setups. Next, we have Amazon Kinesis Data Streams, a managed service with provisioned shards or on-demand mode. Provision mode requires manual shard management, which has medium effort. Understanding throughput and shard limits. Moderate deployment complexity for producer-consumer setup. On-demand mode eliminates shard management and scales automatically, which will offer low effort. Next, Amazon MSK, a managed service with provisioned clusters or serverless mode. So there are two options. Provision mode requires selecting broker types, configuring storage, and managing cluster scaling, which is medium effort. Complex deployment due to Kafka concepts. Serverless manages brokers and scaling automatically, and that is low effort, reducing management. Then Amazon MWAA, a managed service that uses serverless components internally. It requires significant user input for configuration like VPC, S3, its own settings and dependencies, and managing the directed acyclic graphs which are in Python. AWS manages underlying Fargate tasks and Aurora database. Management effort is medium. Deployment complexity is complex, stemming from managing the Airflow application layer and its dependencies. Next, AWS Step Functions, a serverless and fully managed workflow service. AWS handles the infrastructure, resulting in low management effort. Deployment complexity is low to complex depending on the complexity of the defined workflow and integrations. Next, Amazon Simple Workflow Service, a managed service with higher user responsibility. SWF manages state tracking and task dispatching, but users are responsible for developing, deploying, and managing worker and decider components with actual business logic. This leads to high management effort and complex deployment compared to services like step functions. Next set of parameters will be scalability approach, typical throughput, and typical latency. So for Amazon SNS, it offers automatic scaling. Standard mode has very high throughput, which is unlimited messages per second. And there is a FIFO mode, first in first out, has high throughput. It is limited to 3000 messages per second. Typical latency is low to medium and variable. Serverless services generally offer low latency because it's totally serverless. It offers it offers low latency. Means it's very fast. Next, Amazon SQS. It offers automatic scaling. So it has standard mode which has very high throughput, which is unlimited messages per second throughput. And then there is a first in first out mode has high throughput. Dependent on the region and the mode, typical latency is low, but it varies based on the polling mechanism because we pull from the SQS. SNS we push. Long polling reduces API calls but introduces potential wait time. Next, Amazon Event Bridge. It offers automatic scaling subject to regional quotas. Typical throughput is high, limited by region dependent quotas. Typical latency is low. Serverless services generally offer low latency as I talked about. Then Amazon MQ. It requires manual scaling, and part of manual scaling are instance type and size and deployment mode. Throughput is variable depending on instance type, configuration and workload. Typical latency is low to medium and variable depending on the configuration, instance type and network. Next, Amazon Kinesis data streams. So provision mode scales manually by adjusting the shard count. On demand scales automatically up to high regional throughput limits. Throughput is high, scaling with shards automatically. Typical latency is low, under sub-second, so sub-second latency. And there is the enhanced fan-out mode EFO, which provides very low latency, and it's around approximately 70 millisecond compared to standard consumers, which will have a latency of around 200 millisecond. Next, Amazon MSK. Provision mode scales manually by adding or resizing brokers and managing storage. And the serverless mode adjusts compute and storage automatically. Throughput is very high, scaling with brokers and partitions, subject to service limits. Typical latency is low. Managed workflow for Apache Airflow. It offers automatic scaling of worker and web servers within environment limits. Throughput is medium to high depending on the configuration and DAG complexity. Typical latency is medium to high. It is generally not chosen for low latency use cases, focusing instead on batch orchestration. AWS Step Functions. It offers automatic scaling. Standard mode has high throughput, around 2000 executions per second. Express has very high throughput, which has around 100,000 executions per second. So standard 2000 and this is 100,000. Standard has medium start latency. Express has low start latency. Step Functions Express throughput is significantly higher than the standard. Amazon Simple Workflow Service. This service scaling is automatic, but overall throughput depends on manual management of workers and deciders. Throughput is variable depending on the workers, deciders and the quotas. Typical latency is medium to high due to polling mechanism and focus on long tasks. It is not chosen for low latency use cases. Apache Airflow, which is a previous service, MWAA and SWF this service are generally not chosen for low latency use cases, focusing instead on batch orchestration or long running tasks. Step function standard also has a higher start latency than Express. So this is from previous service. Next set of parameters are message event ordering, delivery guarantee, and message event persistence. So first we have Amazon SNS. So ordering is best effort for standard, strict for first in first out. Delivery guarantee is at least once for the standard mode, exactly once for first in first out mode, only to SQS FIFO subscribers. Persistence is ephemeral by default with optional archiving. SNS is primarily used for real-time delivery. Next, Amazon SQS. Ordering is best effort for standard and strict for first in first out. Delivery guarantee is at least once for standard, exactly once processing for FIFO, and this prevents duplication within the deduplication interval. Persistence is queue based, which is between 1 minute to 14 days retention. SQS stores messages until consumed or retention expires. Next, Amazon Event Bridge. So ordering is not guaranteed, it is based on the best effort. Delivery guarantee is at least once with retries. Persistence is ephemeral by default with optional archiving and replay. Event Bridge is primarily designed for real-time event routing. Next, Amazon MQ. Ordering is configurable, dependent on the engine and features. For example, active MQ message groups for strict order. Delivery guarantee is configurable and protocol dependent. For example, at least once with acknowledgements. Persistence is disk based, so it uses EBS and EFS and configurable based on broker settings. Guarantees depend on underlying protocol and configuration. Next, Amazon Kinesis data streams. Ordering is guaranteed within a shard. Records with the same partition key go to the same shard, preserving order. However, there is no ordering guarantee across different shards and partitions. Delivery guarantee is at least once with consumer responsibility for processing and checkpointing. Persistence is stream based, which is between 24 hours to 365 days configurable retention. Next, Amazon MSK. Ordering is guaranteed within a partition. Delivery guarantee is configurable, so it can be at most once, at least once, exactly once. Achieving exactly once requires careful configuration of producers and consumers. Persistence is broker storage configurable with optional tiered storage for long retention. Next, Amazon Apache Airflow. So ordering is defined by the DAG logic and task dependencies. Delivery guarantee is task execution based on the DAG schedule. Persistence involves metadata storage in Aurora database, DAG's artifacts in S3 and logs. Ordering is determined by workflow logic defined in DAGs. Next, AWS step functions. Ordering is defined by the state machine logic. Delivery guarantee is exactly once for standard workflows, at least once for Express. Persistence is durable state for standard workflows, ephemeral state for Express. Logs provide the audit trail. Standard workflows provide exactly once execution of each state. Amazon Simple Workflow Service. Ordering is defined by the decider logic. Delivery guarantee is at least once task execution with retries controlled by the decider. Persistence is durable state, service managed with history execution limits. Ordering is determined by the custom decider code. So next set of parameters are availability design, fault tolerance features, and durability concepts. First, Amazon SNS. Availability design is regional and multi-AZ. It features automatic retries and dead letter queue support for fault tolerance. Durability means messages are stored redundantly during the delivery attempt window. Next, Amazon SQS is also regional and multi-AZ. Fault tolerance includes visibility timeout, dead letter queue support, and configurable retries with max receive count. Durability comes from storing messages redundantly across multiple AZs within the queue until they are processed and deleted. EventBridge operates regionally and multi-AZ with optional cross-region resilience via global endpoints. Fault tolerance includes automatic retries up to 24-hour, dead letter queue support, health checks for global endpoints. Durability is managed through retries, DLQs, archiving, and replication for global endpoints. Amazon MQ offers various availability design. So you have single, you have active standby for multi-AZ and cluster multi-AZ with optional cross-region replication for active MQ. Fault tolerance features include auto failover, quorum queues for Rabbit MQ, and CRDR for active MQ. Durability uses persistent messages being stored on ABS and EFS with replication for EFS and quorum queues. Kinesis data streams is designed for regional multi-AZ availability with up to 3 AZs. Its key fault tolerance feature is automatic data replication across 3 AZs. The durability is built on this synchronous replication across 3 AZs upon data ingestion. Amazon MSK offers regional multi-AZ availability, default 3 availability zones with optional cross-region capability via MSK replicator. Fault tolerance includes auto breaker replacement and multi-AZ replication. Durability relies on Kafka's native replication across brokers in different AZs. Next, Apache Airflow is regional and multi-AZ, deploying components across AZs. Fault tolerance includes multi-AZ deployment and auto-scaling that replaces failed workers. Durability relies on Aurora PostgreSQL for metadata and S3 for DAGs and artifacts. AWS step function is regional and multi-AZ. Fault tolerance includes auto retries and built-in error handling, catch retry. Durability is provided by service-managed state persistence for standard workflows. Logs are the primary record for express workflows. Amazon S2 Simple Workflow Service is also regional and multi-AZ. Fault tolerance centers on durable state tracking and decider-controlled retries for tasks. The durability is service-managed durable state persistence for workflow execution history. So next set of parameters are primary cost drivers, pricing model, and cost optimization strategies. So for SNS, costs are driven by API request, notification delivery by the type, data transfer out, payload size over 64 kilobyte. It's a pay-per-use model with tiered data transfer. You can optimize it by filtering messages, optimizing payload size, and using the free tier. Next, for SQS cost come from tiered API request, and this API request will be send, receive, and delete, data transfer out, and payloads over 64 kilobyte. It's a pay-per-request and tiered model. Optimization strategies include using long polling, batching API calls, payload compression, and choosing standard queue when FIFO isn't strictly needed for cost savings. EventBridge costs are based on events published, that is customer and partners, certain deliveries, and feature usage like pipes, schedulers, API destinations, and archiving. It's a pay-per-event, pay-per-invocation, and pay-per-request model, optimized with precise filtering, optimizing payload size, and utilizing the free tiers for various features. So, when you open a free account, you can get some free tier also, but that may not be applicable when you are working for enterprises because they will usually cross that limit pretty fast. Next, Amazon MQ. The costs are primarily provision capacity, broker instance hours, storage usage, which is GB storage per month, and data transfers storage, like data transfer out, how much they have transferred the data. Optimization involves right sizing the instances, choosing the correct storage type, which can be ABS and EFS, and optimizing client usage patterns. Next, Amazon Kinesis data streams. So provision mode cost are shard hours and put units. On demand cost are data in, data out for every GB and stream hours. There are optional cost for retention and enhanced fan out. Pricing is provision capacity or pay per throughput on demand. This is on demand mode. Optimized by choosing the right capacity mode, right sizing shards, batching records, and using enhanced fan out judiciously. Next, Amazon MSK provision cost are broker hours, storage, and data transfer. Serverless cost are cluster hours and partition hours, data in, data out, and storage. Pricing is provision capacity or pay per use for the serverless. Optimization includes choosing between provision mode and serverless mode, right sizing resources for the provision mode, using tiered storage, and optimizing data transfer. Next, Apache Airflow costs are driven by the environment size, which are the base instances, autoscale worker, scheduler, web server hours, and DB storage. It's a provision capacity model. You can optimize by right sizing the environment, optimizing the DAGs, directed acyclic graphs, tuning scaling settings, and monitoring cost. Next, AWS step functions, standard cost per state transition, express cost per execution plus duration and memory. Pricing is pay per transition for the standard or pay per execution duration for the express workflows. Optimizing by choosing the correct workflow type, either standard or express, optimizing transitions for the standard, and configuring logging effectively for the express. Simple workflow service cost are pay per use across multiple dimensions. So this is execution started, API calls, which are tasks, workflow execution time in days, optimized by optimizing workflow logic in deciders and the workers, managing retention of history, and evaluating if step functions is better fit and potentially more cost effective for new workloads. Next, setup parameters are primary use cases, less suitable for, and the key differentiators. So SNS, it is ideal for fan out notification, application to application, A2P, application to person, mobile, SMS, email alerts, triggering parallel processes. It is less suitable for complex routing, filtering, or durable work queues. Key differentiators are native A2P support, simple fan out model, and broad endpoint types. SQS, it is primarily for decoupling services, task queues, buffering workloads, batch processing. It is less suitable for fan out or event routing. Key differentiators, durable queues, visibility timeout, dead letter queues, FIFO option for strict ordering, exactly once processing. Event bridge, it is best for event routing, event driven architectures, SaaS integrations, scheduled actions, simple pipes integration. It is less suitable for durable message queuing or high throughput ordered streaming. Key differentiators are advanced filtering, routing, schema registry, API destinations, pipes, schedulers, SaaS sources. Amazon MQ, primarily for lift and shift migrations of existing brokers. Protocol specific messaging like JMS, AMQP, MQTT. Hybrid cloud messaging, it is less suitable for simple cloud native decoupling if protocols are not needed. Key differentiators, standard protocol support, managed ActiveMQ and RabbitMQ engine. Kinesis data streams, it is excellent for real-time data ingestion and analytics, log aggregation, clickstream processing, IoT data. It is less suitable for simple routing or Kafka workloads. Key differentiators, AWS native streaming, shard level ordering, long retention replay, enhanced fan out low latency on demand mode. MSK, this is the go-to for Kafka workloads on AWS. High throughput streaming needed around Kafka ecosystem. Event sourcing, databases. It is less suitable for simple non-Kafka streaming needs. Key differentiators, managed Apache Kafka, Kafka API and the ecosystem, any kind of compatibility with Kafka, tiered storage and serverless option. Next, Apache Airflow, best for complex ETL, data pipeline orchestration, scheduled batch workflows, ML pipelines. It is less suitable for simple function coordination or real-time event response. Key differentiators are managed Apache Airflow, Python DAGs, Airflow ecosystem, auto-scaling workers. AWS step functions. It is preferred for serverless orchestration, microservice coordination, business process automation, ETL, human workflows, standard, high volume events, express workflow. So standard workflow and express workflow. It is less suitable for simple message passing or running Airflows, DAGs. Key differentiators: visual workflow, serverless, state management, error handling, and standard versus express types. Simple workflow service. This can be used for long running background tasks. Complex distributed task coordination between worker decider model. Legacy workflows. It is less suitable for new serverless workflows. So you should go for step function or simple state machines. Key differentiators: worker decider pattern, task level control, long execution duration up to 1 year. Next set of parameters are key concepts for certification, common exam confusion points, and important limitations to remember. For SNS, the key concepts for certification focuses on PubSub, topics, subscriptions, fan-out endpoints, FIFO versus standard differences, filtering, and DL dead letter queues. Common confusion is comparing it to SQS, push versus pull. So SNS is push, SQS is pull based model. This is fan-out, so it's one-to-many, and queue is one-to-one. And event bridge, simple versus advanced routing. Remember its limitation. Best effort ordering for standard. FIFO, so first in first on will throughput, the total throughput limits are there, and ephemeral persistence by default. SQS certification key concepts for certification includes queues, decoupling, pull model, FIFO versus standard, visibility timeout, long polling, dead letter queue, retention, and batching. Confusion points include SQS versus SNS, the previous one. So SQS queue and SNS is topic. And SQS versus Kinesis and managed service for Kafka. So this is messaging, and Kinesis and MSK is streaming. So this is the difference. Streaming means there will be very huge volume, non-stop, no end to data, unbounded kind of data. So for that you will use Kinesis or Kafka. Key limitations are standard ordering, duplicates, deduplicates, FIFO throughput limits, so the limits on where if you go for FIFO queues, and max message size. So this has 256 kilobyte maximum message or the payload size. Max retention is 14 days. These are all the hard limits. Event bridge. Key concepts for certification requires knowing about event bus types, rules, targets, filtering, which are event patterns, pipes, scheduler, API destinations, archive replay, and global endpoints. Confusion arises when comparing it to SNS. This is routing. This is because this has routing depth, and SNS is, as I talked about, is push based. It can have very huge amount of routing rules and all, so that will come handy when you want to go for event bridge. And next, confusion comes with SQS service. So again, these are events versus messages. Limitations include no ordering guarantee, regional quotas, transaction per second, and default targets per rule limit, which is 5. Amazon MQ key concepts for certification focuses on managed ActiveMQ, RabbitMQ engines, supported protocols. So if you exam says some protocol which are JMS, AMQP kind of protocols, then you know which one to choose. Instance types, high availability modes, and engine features like CRDR and quorum based model. Confusion points comes from comparing it to SQS and SNS. So SQS and SNS, this is a managed broker-based service which depend on the technologies which I talked about, ActiveMQ and RabbitMQ, versus native. SQS and SNS give you native integration and they are the native proprietary services and understanding its use cases. So this is migration if you are migrating, or if there is any kind of protocol dependencies which I talked about, like JMS, NMS, AMQP. And some limitations, this is not serverless and others are serverless. It needs manual scaling, higher complexity than SQS and SNS. It requires engine specific knowledge. Next, Kinesis data streams. Key concepts for certifications are shards, partition keys, ordering in shard, retention, provision versus on-demand mode, enhanced fan-out, Kinesis client library, KCL, and resharding. So common confusions are comparing it to SQS. This is streaming and SQS is queuing. So this will generate maybe very small data but unlimited like throughput. So this is stream of data, and queue is basically you have some kind of like control. It's not like streaming where it's like unlimited data, unbounded. There is no start and end. And messages, like we treat messages bit spatially, but streaming event like this is like we just have to consume and do some kind of like store it or do some analytics on that, on top of that. Next confusion or comparison will be MSK, Kafka service. So this was the original. So this is native service. Then came Kafka because they want to support and help customer migrate or provide the compatibility with Kafka ecosystem. Then that was introduced. So go for MSK if that is those limitations or requirements or constraints are not there. And lastly, Firos and analytics. So Firos, Kinesis Firos is basically you store it, you buffer and store it. So destination, so that is also native AWS service. And Kinesis analytics when you want to run some analytics. And limitations, there is no cross shard ordering guarantee. Shard limits, there are some throughput and reach, there are limits in place, and enhanced fan out consumer limit, so which is 20, which is the default. Next, Amazon MSK. Key concept for certification include it's a managed Kafka, then there are brokers, there are partitions, there's provision versus serverless mode, it has tiered storage, security, it offers MSK Connect and Replicator. These are Kafka components or the Kafka technologies. So some confusion comparing it to Kinesis, which I talked about, Kafka versus native AWS versus self-managed, because this is self-managed and that is totally serverless. Not serverless, that is also managed because you will see the shards and partition management, shard management will be there. And provision versus serverless trade-offs. So MSK has these two modes and you can go through the trade-offs. Limitations, provision requires manual scaling, serverless has specific limits on the number of partitions, etc. And Kafka concepts and complexity. So Kafka is a bit complex technology, so you should know, and only if there's a migration or there's some constraint where the customer want to use Kafka, then you will go for it. Next, Apache Airflow. So key concepts for certification covers managed Airflow, directed acyclic graphs, workers, schedulers, environment class, S3 integration, auto scaling and security. Confusion points are comparing it to step functions. So this is Airflow versus state machine. One is making sure some technology which is being used outside is also offered to the other customer versus native proprietary technology. And then we have batch ETL. This is batch ETL versus step function, which is serverless orchestration. Limitations, complexity. So you need Airflow knowledge. Potential cold starts. So that issue is there. It's potential, but it's not always, but potential. Update process requires downtime, and networking setup is the key. AWS step functions. Key concepts for certification involves state machines, states which are tasks, choice, etc. Then workflow type, standard versus express. Amazon state language, ASL, which is in JSON format. Service integrations, error handling, retry and catch mechanism. So common confusion versus simple workflow service. So this is modern and this is the most recommended one versus legacy. This is visual and that is code. Standard versus express differences. So use cases, that guarantees that it offers. So there are some limits and limitations. Standard has lower throughput. Express has a 5-minute limit and limited history. Simple workflow service. Key concept for certification focuses on workflows, domains, workers, deciders, tasks, activity and decision tasks, visibility, long running executions. The primary confusion point will be versus step functions. So legacy versus modern. Limitations, complexity, requires worker decider code. It is considered a legacy status service and integration is API driven. So it's less visual. And that's all. Thanks for watching.